So as we discussed, we saw what is dijkstra algorithm, and remember, do pronounce it right. Dijkstra algorithm. Okay. So for making this algorithm, we'll take the codes and we'll introduce two simple functions, which is easy to understand. So please follow me. The first one is initialize single source, and the next one is relax. So over here, the parameters that we take is G, W, and S, where G is the graph. In this case, what we're gonna see is a weighted directional graph. Okay, and excuse me, and S is a source vertex. That is, we take from which source point do we want to take. We start with S. So this is a source point and we compute the direction from S to all the other points. Okay. Whereas the weights are nothing but from, if you say from S to D, okay, the weight of this is 5. So that's it. And okay, so let's go and initialize our first function, that is initialize single source. Now when we initialize this, we pass the graph along with the source vertex. Remember, we have to specify some starting point of this graph. Say for example, if it's A, well, from A to all the other points, and if it's S, from S to all the other points. Well, we see in this before algorithm, like in minimum spanning tree, what happens is the graph is just made from whatever starting point, and there are the formula n minus those graphs. But over here we have to specify from where we are starting. Okay, so let's just go initialize this function. And when we initialize this function, see, look at this. For each vertex v which belongs to vertex of the graph, so for each vertex v which belongs to the vertex of the graph, initialize infinity. So we don't know from which position how much distance, so we'll just initialize infinity, 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 infinity. Okay, and the parent of v is equals to null. So the parent of v we do not know, so it's null. And then the distance of s initialize 0. So since we're taking the source part, we'll initialize this as so. This step over here initialize 0 to the source distance. Now technically the source distance is 0. Okay, and then so when this first sentence executes, this is what the graph we get. The distance from the point to A and B and still is infinity, assign it. And the parent, so the parent, what is parent? Maybe maybe to reach D we have to pass from S to A to D. No, just for sake, that means the S is being reached through A, so A will be the parent for D. Okay, so the next thing, just after completing this, is we would like to complete and execute this sentence. S belongs to like 5, that is the value phi is being stored in S. Right now at start, we don't have any optimal solutions. Okay, so whatever your initialization phi is like nothing. Okay, nothing. And the main point of this flow is from nothing to just making the shortest single part. Okay, so for the optimal solution, yes, we first it's 5, and the next one for vertices of the graph, assign it in a queue. Okay, and the meaning for this is the vertices goes one by one. Okay, so it goes in a small queue format, and it passes through all, such that it passes through all and it forms a queue. Now, while this queue is not phi, nothing, so just meaning that one circle should go through the graph consisting of A, B, C, D. So it should go in a flow, and once each flow it goes from the respective, say from S to A or B. Okay, we extract the minimum of the say this, and we save it in U. Understand? So basically that's what we're going to do. So now, according to rules, it's going to iterate through this entire vertices. The meaning of this sentence: while q not equal to phi, do extract minimum in one loop minimum. So now in our right this one, the minimum is now S. So we take S and keep in U. So right now here over here. Now the last step we came is we take S, which is the minimum, and keep it in U. So for our first iteration, U is equal to S. And the next one is a quite tricky one. This U, what we get is get appended in the main solution. So it's getting locked kind of. That is S first iteration is getting locked. Okay, and once S gets locked, next word, for each vertex V which belongs to the adjacent U, do relax U V W. So for S, which is the adjacent, pass to the second function, which is relax U V W. So as we came, the next we have to execute is for each vertex V of adjacent. So for S vertex, if U is equal to S, for S there are two vertices, so B will become A, comma D. Okay, now just after this, for each A as well as D, it runs a loop and it calls relax UVW. That's nothing but relax of S for the vertices A or D and the weight from S to A or S to D. Okay, if D of V is starting infinite, okay, is greater than D of U. D of U is 0 plus weight of U to V. Weight of U to V is 10. Then assign it. Now this is lesser, so assign it to the new dv, and parent should be u, which is s. Okay, so now we change it to ten, and the parent u is assigned to uv. Yes. Now the same repeat. Now for v of a is over. Now for v of d, if d of v is greater than so d of v infinite, so d of v is infinite greater than d of u. D of u is 0 plus weight of u to v. Now it is s to d. S to d is 5. Now since it holds good, this 5 is replaced for du and u value is replaced to v. So dv so that's it over here. And next we complete this iteration and we go to while loop again. Now when we go to while loop again, the same thing runs. For q, when it is not empty, extract the minimum of the q. Okay, now in the queue only s has been over. Okay, and the minimum for all the weights, assign it to u. Now what is the minimum next? You have d. Okay, so for second one, d equal to 5 and u equal to d and v equal to, from d, so from d we can go to c, we can go to b, and we can go to a. So it is a, b and c. Now remember, yes, s union u. So in the main solution u is added. So our u has been added, this both, and for each vertex of v that belongs to adjacent u, do relax. So for same u of a, then b, then c, for these three things the same thing is done. Okay, so first one, u, um, so for d of u, if I'm taking a first, for d of v is nothing but 10. So 10 greater than d of u. Now d of u is 5 plus weight of u to v. So d to a is 3. Well, this is 8 and it is lesser. So the less value gets updated to dv and it is passed via d. So it gets updated over here. Eight and value to d. Now next value is b. Now what is same for p value? D of v from d to p. So b value is actually infinity. So infinity greater than d of u. D of u is 5 plus d of weight of u to v. U is 5 and from D to B 9. 5 plus 9, 14. Okay, 9, which comes down to 14. So D of V is 14 and parent of vertices is D. So when we go to B, the value changes to 14 and it is passed via D. The same thing to C also. No, the weight of dv C is infinity, is greater than weight of du, that is 5, plus weight of u to v. So d to c, well, d to c, so d to c is 2, which is 7. So d of uv is 7 and parent is d. So seven D. Now, so the loop runs over here, and after the relax is over, it again goes to the while loop, and since over here only 2 is over, still we got 3. Now among these 3, which one is the smallest one? The do the minimum, extract the minimum of the q and keep it as u. So the next one, third one will be u of c, and c equal to 7. So now up till here is over, and we place the new u into the main solution. So this c is also done with, and the next step is for each vertices of v that belongs to the adjacent u. So for c, the adjacent matrix is nothing but b. So b is nothing but b, and now if we do the same over here, okay, this time see, um, in relax, d of v, that is d of v of the vertices is 14. It's greater than d of u is c, and it is 7 plus weight of u to v. So from c to b, it is 6, and it is lower, so yeah, it gets passed, and the parent is u, that is c. So we updated 13 and c. Okay, and the second iteration takes place. Again it goes to while loop again. Now over here still 2 is left, a and b. Among this, now the smallest minimum is a, so a is taken, s is kept in the solution, and the next one is fourth one for u equal to a. No, from a there is we can go to b, and we can go to d, but d is already in the solution thing, so only option is we to go to b. Okay, now the same d of v d of b is actually 13. So 13 greater than the d of u, which is a, and it is 8. So 8 plus 8 plus u to b. So a to b is just 1, and its value is 9. So, and the parent is u, that is a. So 9a. Now just after this is over, we are left with b. So it again iterates while the last one is b for minimum of q, and since only b is left, b gets added to the main solution, and for each vertex b of adjacent b, which it doesn't have any adjacent matrix for b, so the iteration stops, and this is our solution. So the dijkstra algorithm, now we got A, B, C, D. A, B, C, D. Okay, and okay. Now, how did we reach till A? Mm, so, how did we reach till A from D, and from D, S? Okay. Next, B, we reach through A. Again, A, we reach through D. Again, D, we reach to S. And C, we reach to D. And D, we reach to S. In D, we reach to S. Now, so this is the exact solution for this customer. Okay. And what actually happens over here again? We initialize the single source for the graph and the solution, and the source and the weights. We just pass it through if phi, that is the first solution, is nothing and empty. Then we pass the vertices in queue format one by one, so everything should pass. Now, when everything is passed in a loop up till all the vertices are completed, from one vertex you just map it to all other vertices, but before that you extract the minimum weight of the vertices. And for that, when you extract this, three things happen. All the starting things are given infinity, then your parents are given null, and then the starting S is just given 0. So for this, now you map it. The first one, that the minimum thing comes, it goes into the solution, and for each vertex you map it and do relaxation. Now, what relaxation simply means? Relaxation, if you see, is just the minimum distance from the before one. And say at certain point, when we found that the value 14 got changed to 13 and 13 to 9, that means that if we have found a much more shorter distance from any other vertices, then we just switch it. So the relaxation goes, whatever the current weight is, if it's greater than the current position plus that position to this before one, so relaxation takes place, and finally you get the single sourced shortest method. And like we discussed, that's it.